Today, it will be all about graphs of quadratic functions, which are parabolas, and we've talked about these. These are the U-shapes that we saw at the beginning of the year, the horseshoes, and sometimes they go up and sometimes they go down. But for today's class, it's all about trying to find a couple key aspects. So by the end of class, you should be able to identify the axis of symmetry, the turning point, and the zero values, which I'm going to relate those zero values to factoring a trinomial. So that whole X concept that we did last class. And for some of you that turned into homework, very nice job with that. So let's talk about those solutions, those zero values. Where the parabola crosses the x-axis, that's where you'll find the zeros, the X-intercepts. Oh, thank you. Those zero values are x-intercepts. It's where the parabola crosses the x-axis, and it gives you a x value for when the y value is 0. So there's kind of the common sense behind that. The axis of symmetry, that is a line that could be drawn through the center of the parabola and basically cut it in half. And it would have like a mirrored effect. Think about drawing a line down the middle of your face. Down your nose, between your eyes, through your mouth, and down to your chin. Your face has symmetry, unless you've maybe been in an unfortunate accident, but everyone is born with facial symmetry, and that is kind of similar to what we're talking here, where that line would be. And then we go into domain and range, which I'm not going to talk about. It's in the completed notes if you want it, but just kind of too much at this time. And then finally, the vertex. Now the vertex is the point at which everything kind of changed. So the TP, we call it, for turning point. And hopefully some of these vocab terms are a little familiar to you. One too many. All right, so let's get going with the first one. We're going to sketch a graph of this parabola, this quadratic, because it has a x to the second power. That's the key. Whenever it's x to the second, it's no longer linear. It's now a parabola. It's a quadratic. We're going to make a table of values, which is just a list of all the points from this, and that's why we need our graphing calculator today. So go ahead and grab your graphing calculator and follow along with me. Where is it? So once I've typed it in, I go to my table and I can arrow up and down to kind of change the table. So if you're not seeing what you want to see, don't be afraid to go up and down in the table because your calculator may not be in the same position as mine. All right, back to the notes, and I'm just going to write down what I had in my calculator. So it's -3, 7, -2, 0, -1, -5, 0, -8. Oh, yes, 0, -8. 1, -9. I'm out of room, so I'm going to make another column here. 2, -8. 3, -5. 4, 0, and 5, 7. Quite a few points to take into consideration here, and we'll have a reason for that in just a minute as we put these on the graph. So again, these are just points that you can plot by moving left, right, up, and down. So -3 in the x, up 7 in the y. 1, 2, 3, 4, 5. If I get too close, they show up. Sorry about that. -2, then move 0. Then 1 to the left, down 5. And then it's 0 left to right, down 8. There's our y-intercept. Then it's down 9. But then after that, it's symmetrical. So again, it's going to look the exact same, but just have a different x value. So we got a -8 at 2. We've got a -5 at 3. We've got a 0 at 4. And we have another 7 at 5. So that should look like a U shape, a symmetrical U shape. Go ahead and connect the points, put arrows on either end, and it's never a bad idea to put a label on it. Okay, so now let's talk about what we need to do today. One is identify the axis of symmetry. So I'm going to use some cooler colors here. Axis of symmetry is the line that I can draw right down the center and split it into 2. Now that line is vertical. Remember what vertical lines start with? They start with x. So this is going to be an x equals line. Now, what is the x value for this line? Well, it's right here at 1, right? So this is simply x equals 1. That is your axis of symmetry. Now, what about the TP, the turning point? Well, that is this point right here. Because everything changed. It was going down and then it went up. And so that point can be found by looking at the table and seeing that -9 had no match. This was your TP. So this point, 1, -9, your turning point. And what about our 0 values? Let me pick another color for that. Again, these are called zeros or roots or x-intercepts. Apologize for all the different numbers, but basically it's where it crosses the x-axis. These are 0 values. Why do we call them 0 values? The y value is 0. Now this happens at an x value of -2 and an x value of 4. We can see that in the table as well because we have a -2, 0 and a 4, 0. So call this x equals -2 and 4. Like I said, I'm not going to talk about domain and range, just a little bit too much to cover all in one virtual class, but I am going to talk about how we can factor this trinomial. Very similar to what we did last time. So remember when we had a number that we added to and a number that we multiplied to when we tried to break that up into 2 binomials? Yes. So let's go ahead and take 8 and list the factors of 8. 1 and 8, 2 and 4. Now I know that some of you found the x to be very helpful, which is awesome, but you don't have to always use it. You can kind of just use your number sense in order to come up with this. So x squared, we break up into x with x, all right, one x there to lead and the other x there to lead. And then I got to try to think about the pair that's going to add to -2. Well, 1 and 8 is not going to get me to -2, but 2 and 4 will. So I put the 2 down here and the 4 here. But now I'm stuck with the signs, right? I got to get the right signs or else this isn't going to work. It multiplies to a -8 and adds to a -2. Well, if it multiplies to a negative, signs have to be different. If it adds to a negative, bigger numbers got to be negative. So 4 is bigger, that's the negative. 2 smaller, that's the positive. Signs are different, bigger number negative. Now, how am I getting the 0 values out of that? Because my 0 values are a little different. -2, +4. Well, what did we just say? We said that we were going to make the y value 0. So that means y becomes 0. And I'm going to rewrite what we just had. Now you're just going to have to believe me here. We can break this up into 2 pieces, 2 equations, where 0 can be equal to the first binomial and 0 can be equal to the second binomial. If you'd like, at the end of class, I can go through a whole presentation on why we can do this, or you can just say, I believe you, Mr. Petrie, totally fine. Now, we got 2 small equations, simple, easy little equations, right? Where we subtract 2 here, and we subtract 2 there. We do it to both sides, and voila, our x value is -2. And then over here, I'm going to add 4, and so 4 is equal to x. And there you have it, folks. That is the algebraic way to find 0 values, where you would factor, set each piece equal to 0, and solve for x. Or you could do it with your calculator. So I wanted you to be able to know how to factor. That's why we did Unit 7, Practice 1, or Notes 1 last class, before we went into what we were going to talk about today with using the graphing calculator. So I hope you understand my reasoning for the order in which I chose to do this. I'm going to do one more of these, so if this isn't making a lot of sense, give me the chance to do one more, and please ask me any questions if you have any. All right, next one. we're going to have to type in this to our graphing calculator. So let's start with that. Go to y equals, clear out whatever was previously there. And if you're wondering where this is on the notes, we're on the back. Example number 2. So this is x, square it by pressing x to the second power, minus 4x, and add 3. I hope you're good with the calculator. We haven't used it as much. I mean, I'm only up to like notes 20 or so we've only done like 20 lessons or so. Obviously, we haven't used the graphing calculator every time, but I hope there's some things there that you're able to remember from previous classes. Now from there, second graph, and that pulls up the table. And again, I'm looking for that rainbow. I'm looking for those values in the y column to kind of have a match. And if I scroll down here a little bit, I'm going to start to see, yes, an 8 with an 8, a 3 with a 3, a 0 with a 0, and then a -1 that's in the middle and kind of gives us that idea of a U shape or a rainbow. Let's go ahead and get that down as a table of values. So simply x and y. We've got the values we need. Let's go ahead and plot points. So 1 to the left, up 8. And then 0 to the left or right, and up 3. I gotta get rid of that. Sorry. And then it is 1 to the right, right on the x-axis. That's going to be important later. 2 to the right, down 1. And then we start to go in the other direction. We start to go up. So that's 3, 0. 4, 3. Again, these are going to have the same height because it's got to create that U shape that has symmetry. Symmetry, you say? Well, let's get some colors out and talk about the line that goes right through the middle, called the Axis of Symmetry. It's a vertical line, so we know it starts with an x and not a y, and it uses the x value. This x value right here is a 2. Axis of Symmetry is x equals 2. Turning point. We saw it in the table. We can see it right here. Whoops, let me go to new color. Saw it in the table. We can see it right here at the bottom. It is simply 2, -1. That's also called a vertex. It sucks that there's so many different names for all this stuff. We'll try to keep it straight and use just one version. Next up, like I said, lots of different names. Zeros, roots, or X-intercepts. I'm going to identify them as 0 values today. And so that is, forgot to change my color, here and here, right? Where it crosses the x-axis, where we see a y value of 0. So right here and here. So x is equal to 1 and 3. That's when the y value is 0. Not talking about domain and range today. We are talking about how we factored last time. Okay? So let's write this trinomial as 2 binomials. We're adding to this number, we're multiplying to that number. We want to make a quick factor list of 3. And when I say quick, it's going to be real quick because it's a prime number. Only 1 and 3. So that makes it easy. We put 1x here and 1x here because of the x squared. I put a 1 there and a 3. I'm going to ask the audience. So I went with a negative and a negative for my signs, and now I want to find the zeros. I want to find when y is 0. And I told you that you're just going to have to trust me on this one. Okay? And so 0 can be equal to x minus 1, and 0 can be equal to x minus 3. We're just going to split these up in 2. Now I'm going to add 1 to solve for x here. I'm going to add 3 to solve for x here. All that does is cancel it on this side. It gets the x by itself, and voila, 1 here, 3 there. The same thing you saw when you graphed it. So my suggestion, when you are asked to find the 0 values on a possible regions this year, put it in your calculator and find where it crosses the x-axis. Even faster than factoring and solving an equation. Okay, folks? So there you have it. That is actually